All right, let's go ahead and get started. How's everybody feeling? It's 9:30 in the morning on a weekend, so thank you for coming. Got some thumbs up, so that's good. Who went to the party last night?
Right.
You're the real champions here. Was it good? I didn't go because I figured being hungover and trying to do this would just be no good. No good. All right, so thank you for coming out today. Today I'm going to talk to you a little bit about REST API. So quick show of hands, I know I already asked this. Who here's a developer? All right, any sysadmin DevOps types? Got a few of those? Okay, cool. So my name, technical writers, awesome. I started as a tech writer, so yes, good stuff. So my name is Amanda. I'm a developer advocate at GitLab. I am just your average consumers of APIs and IPAs, except for last night because I did not want to be hungover doing this. I grew up around computers, tinkering and all that stuff. Kind of didn't really know what an API was until I started making them and then realized, like, hey, this is actually a thing. So that was kind of cool for me. I'm pretty much a professional conference attendee and tinkerer. Very fortunate to have a job that pays me to travel around and give talks, just like this one. Also, motorcycle enthusiast. This is my motorcycle helmet. So APIs are everywhere. Pretty much using web services these days, you're probably taking advantage of an API. The Twitter app, the Facebook app, pretty much any mobile app, but especially mobile apps from Twitter and Facebook are using APIs. If you're deploying on AWS, which I apologize is very hard to see on here, you're likely making use of their API. DigitalOcean, Google has a ton of APIs for just about anything, cloud services, JavaScript APIs, and all that. So they're really everywhere, and this is kind of an area that is really growing in adoption. You're starting to see more and more APIs, and people have kind of hopped on board the API bandwagon, and they're like, we need an API. But they don't necessarily know what that means. They know what an API is, but they're not really sure how to implement one. So that's what we're going to go over today. There are a lot of considerations that people, unfortunately, do not consider when they're rolling things like this out. So, great, APIs are cool, but why should you care? They provide a uniform interface for interacting with your application. So if you have a web front end to your application and you have some stuff going on the back end, you can expose that back end portion via an API to do things in the front end. And then that lends itself to creating cool stuff like a mobile app. Allows you to decouple some of your services, so rather than creating this huge monolithic app that does all of the things, you can create separate, smaller apps that do one specific thing, and sometimes that's easier to maintain, sometimes that's not easier to maintain. Going into service-oriented architecture is a little outside of the scope of this talk, but if you're into that sort of thing, it can become pretty cool to manage things that really only do one specific thing. And it froze. All right. There's a few different types. I assume many of you have been doing this a while. You've probably come across these before. Win32, C++ APIs, OpenGL APIs. There's a few different types of web APIs. You got SOAP, XML, RPC, REST. How many of you are working with any of those right now? Cool. Awesome. That's good. So yeah, tons of different types. Today we're going to focus a little bit on the web API portion of this. So what is SOAP? Stateful, includes this cool thing, WS security, so you might see a lot of SOAP in use at financial institutions, insurance institutions, making use of the built-in security with all of that. Most of the procedures for SOAP are obvious. You have like a get record or a delete record procedure that does a thing. Usually you need to know that procedure name, and usually need to know the order of the parameters as well. So that can be kind of a downside, and especially for people who are new to consuming APIs, it's actually kind of a barrier to entry for them because they just want to go in and tinker with things. You know, you find a new cool thing and you just want to dive in and play with it. Don't necessarily want to read pages and pages of documents about how to get a record. So it can be a bit difficult. But today we're going to talk a bit about REST. And this is rapidly gaining adoption. People are kind of figuring out, hey, you know, we don't necessarily need SOAP. We're not making use of a lot of the things that SOAP offers. And this is typically more or easier for people to get involved in. Usually HTTP based, doesn't have to be. I know a dude who kind of created a REST API via FTP. So you can do stuff like that if you want to. I don't know why you'd want to do that, but it's possible to do if you're interested in doing it. No need to know the order of the parameters in most cases, and you can return pretty much whatever you want. A lot of people are returning XML with SOAP. With REST, you can do XML, JSON. I know a few people who are doing YAML. People returning like actual JavaScript that can be run. That's also a thing if you want to do that. So there's a whole bunch of really cool stuff going on with REST right now. So you're probably thinking, all right, cool, let's go ahead and get started with that. And unfortunately, no. This is where people begin to make a lot of mistakes. They kind of cowboy into building an API. Oh yeah, you know, I'm gonna look up REST. I'm just gonna go build an API. Well, that's great, and you can definitely do that for weekend projects. If you ever want to deploy something into production, might want to take a bit more time to properly design this. And the best method of creating an API is designing something that meets people's needs. So before you even get started with this, you need to make sure you're actually building something that you're going to want to use and that your target audience is going to want to use. So sometimes that's going to be you, sometimes that's going to be third parties. Whoever you're building this for, you need to design with them in mind instead of just deep diving into this and not doing any research whatsoever into what stakeholders are looking for. And people do this all the time. Sometimes it works for them. More often than not, it results in failure, and you end up with several versions of an API. And we'll talk about how hard it is to deprecate a version of an API here in a little bit. It gets pretty gnarly. I heard someone snicker, like, you have experience with that? Okay. So, slow down. The idea here is to build a solid foundation that you can then iterate on. And if you kind of build this out properly, then you don't really need to release versions, because if you release new things, as long as you're not breaking backwards compatibility, then you're fine. You can keep adding on that, and your API client should not care. Don't try to join the other million people who are trying to get their API out the door as quickly as possible. You'll notice in a lot of cases, people who do that end up with version 6, 7 of their API. And you don't want to be in that position, maintaining several different versions of an API. I'm here to tell you, having done it, it sucks. Got a nod. Froze on my end. This is awesome. I love the freezing computer. So when you sit down to design this, design it with these things in mind. This is supposed to be an immutable blueprint. You should not, once you actually have the design in place, you should not be straying from that design. This is a contract between you and your users. That might be a contract between you and yourself, might be a contract between you and your manager, or you and your customers. And this is especially important with your customers because they tend to get kind of angry when things don't work for them, right? And don't be afraid to share. You know, the worst feedback is the feedback that you don't hear. As you're designing this thing, you absolutely should be sharing with people and share your design docs, even if it's scribbling on a napkin. I've definitely done that before. Scribbled some crap in a notebook and was like, hey, you know, do these endpoints make sense? Would you be able to do the things that you expect to do with something like this? And sometimes people are like, no, I have no idea what you were on when you created this. Like, what even is this? And sometimes people are like, yeah, this will work for me. So you never know. And in those cases where people were like, I have no idea what you're trying to do here, it was great to get that feedback because I refactored the entire thing and didn't write a line of code to do it, which was great. Actually saved me a ton of time. Be sure to count for your existing architecture. So if your architecture has certain constraints that are set up, you know, feel free to factor those into your design. Sometimes you'll have to, you won't be able to implement certain things, or sometimes you have to do a bunch of crazy workarounds in order to make some of this work, and it's not as streamlined as it could be. That's okay. Account for that, because refactoring your entire app just to make it fit into an API doesn't usually make sense for a lot of people. If you're going to make changes to this design, make sure they provide actual value. Don't just change things for the sake of changing things. You know, if you're adding an endpoint, that's actually kind of a big deal. Don't just add an endpoint for the sake of adding an endpoint. And a lot of people do stuff like that, and it doesn't really add a whole lot of value. Sometimes you can even introduce breaking changes and not even realize it. So just be really careful when you're doing stuff like that. And above all else, design for uniformity. You kind of want, as you're building this thing, you want each endpoint to have kind of a similar feel to it. So people, can kind of guess where you're going with some of these endpoints. Going back to your audience, know your audience, you know. Who is this for? Is it going to be an internal API? If it is, that'll afford you a little bit more wiggle room. You know, you can make some mistakes easier. That's okay. Well, maybe it's not okay. Maybe your manager actually really will not appreciate that. But typically, you can get away with a little bit more. Is it for someone else? Is it a business partner? Are you interacting with third parties, customers, or whoever? And what's the incentive? You know, why is this API going to be beneficial? And that's a question that a lot of people don't answer before they start building their API. And they end up with these things that really aren't all that useful to anybody who is supposedly the target audience here. So if there's no incentive for people to use your API, they're just not going to do it. And you've invested a whole bunch of time and a whole bunch of resources into something that's not even, you know, there's no ROI on that if you're measuring anything like that. So definitely do not be afraid to ask. Your stakeholders will be more than happy to tell you what they need. Sometimes tersely, sometimes they'll be friendly about it. Doesn't matter, get that feedback. Especially if they're going to be terse with you about it. Those are the people that are going to hit back hardest if you manage to mess this up. So difficult, but really, really worth getting that feedback. Regardless of the version of the API that you're doing, you know, maybe you already have one in production and you're working on V2. The feedback that you receive should make it into your spec unless it's just completely illogical. Somebody's like, if you are Twitter and somebody's like, yeah, I really want an endpoint that shows me recipes for, you know, things with bacon. That doesn't make sense for Twitter. Well, I could see them actually doing that, so maybe that's a bad example. But, you know, in general, it would not make sense for Twitter to have an endpoint that exposes recipes that include bacon. So, you know, kind of use your best judgment with stuff like that. You know, sometimes customers ask for things that they don't really need, and there's usually a better way to, well, not always, but sometimes a better way to get them the things that they need without doing a whole bunch of extra work. You coming in? Can someone let him in? And like I said, build something that people want. You know, don't just go build a thing and hope that people are going to use it. If people are not interested, then they're not going to use it. And like I said, you've got all of this engineering time invested in this thing that is not getting any traction. So as you're doing this, there are a ton of spec tools that will kind of help you build this out without writing a single line of code. API Blueprint is gaining popularity. Swagger is taking off. It was something that started a few years ago, but is becoming super popular. They've actually built a really good ecosystem around it, to the point where once you build your API spec, there are even utilities that will write an SDK for you. The SDKs, in my experience, not always the greatest. You really should have like a language expert or someone who has experience with that language go over it and just kind of make sure that there's no like glaringly obvious problem. But in general, like if you're a one-person shop and you need, you know, Java SDKs, PHP, Ruby, whatever, this will get you there, and that's actually kind of cool. And they're refactoring that all the time, so it's getting better and better. RAML, same sort of thing. It's another spec tool with a pretty good ecosystem as well. So, you know, the list goes on here. There's new tools coming out for this all the time. There's even a few where you can pretty much upload your spec and it will generate SDKs and just download them to your desktop for you. So let's get into the nitty-gritty of what is REST. So a lot of people think they know what REST is, and they have a pretty good overview of what REST is, but they don't necessarily know some of the implementation details. So REST stands for Representational State Transfer. That's just a fancy way of saying if you request a picture, you're not actually getting that file. It's not getting removed from the file system. It is a representation of that image. So you are getting basically a copy, and that's pretty much what REST does. It deals with representations of data. HTTP-based routing and methods, so put, get, post, all the things that we're familiar with just by virtue of browsing the internet. And it's stateless. There are no sessions, and there's this concept of Hadios, which will allow you to navigate around your API, and we'll deep dive into that in a little bit. So you have this concept of a resource, and this is just an endpoint into your application, kind of acts as a gateway. So you might have a user's endpoint, or if you're Foursquare, you might have a places. Whatever, you're going to know your endpoints. Hopefully, if you don't know, hopefully your customers are going to tell you the things that kind of make sense, and you'll start to get a good picture. In general, the actions, put, post, attach, all that, are mapped to CRUD actions, so you can create things, read things, update, delete things. So here you're using like get versus a get user procedure like you would with SOAP or something similar, or XML RPC. In general, I advise people to use plural nouns. You never know when you know users versus user, and that's cool if you're going to do something like collections. Maybe you want to return a collection of users or a collection of places, and then places make sense. Even if you're only returning one, you know, in theory, since you have an endpoint for this, there's multiple places, so it just kind of makes sense to use some plural nouns. You know, don't put procedures in your resource names. So none of this get user, get message, anything like that. That's all taken care of by the HTTP verbs. So let's talk about these action verbs for a little bit. So HTTP, anyone not familiar with HTTP at all? Okay, good. I've had people not know what I'm talking about at all, so I can explain that if needed. So typically these just tell the server what action you want to take. Not going to go into the spiel because everybody knows what HTTP is. Good. So let's talk about get. Get data from a resource. If you browse the internet, you pretty much do this every single day, or every time you browse the internet. Uses a query string to tell the API what data to retrieve. Even as you're browsing the web, you can usually see these query strings in your browser with some information. If everything's all right, it returns 200 OK, and it's not always 200 OK, and we'll get into that in a little bit. But in general, get 200 OK if it's all good. Post. You're familiar with this if you're sending forms. This is used to create or manipulate data. Relies on a message body being sent. So instead of a query string, you're actually sending a message body in this request. If you're creating a thing, return 201 created. And ideally, you should return a URI to the newly created resource. And a lot of people actually leave that out, and that's a really important feature of building a REST API is, I've created a thing, now where do I find it? And that's helpful to you as the maintainer of the API because it means lower overhead, people making less requests to your API if you give them the thing that they want. So let's talk about put. You got to be careful with this one. Yes, you use this to update a resource, but you need to include the entire resource entity. So if you have an existing object there, this is going to overwrite that. So a lot of people don't allow this, and that's okay, because you can, well, not necessarily you, your users can kind of get into some really bad situations and delete the data that they are trying to keep. So you can kind of protect people, save them from themselves by not enabling put. But make sure if you are using it or not using it, make that consistent across your API. You know, if you don't allow put on an endpoint, don't allow put on any other endpoints unless you have a really compelling reason to deviate from that. If you're creating a thing, 201 created, you can't use put within the resource itself without an ID, so you need that ID. And this should never be used to wrangle partial updates. That's just creating a mess. Like I said, you need to put the entire object there, and that means you need to know the information beforehand. Some people don't always know that. So don't use this to do partial updates. You should only be doing new things if possible. So let's talk about this guy. Patch only updates the properties provided in the call. So this one is a lot safer, especially for new people who don't know what they're doing. Some newer users are baffled by put, like I said. So patch is a little bit friendlier for you and for people trying to consume your API. If everything's all right on a successful update, 200 OK is fine. You're not necessarily creating anything. If nothing has changed, then 304 not modified. We'll talk about the HTTP status codes in a little bit, but the status codes are actually super important and often overlooked. There's a lot of APIs out in the wild that just return 200 OK for everything, even if there's a failure. If you know, authorization errors, there's a status code for that, and people will be like, yeah, 200 OK. Okay, here's a message body with an error saying, you know, you're not authorized. There's a code for that. And delete does what you'd expect. Ideally, you don't want to allow this on an entire collection. So don't allow someone to delete all your users, yourself, your users. Be very, very careful about this. If you are going to allow something like that, limit it. Maybe limit it to 5 or 10, some sort of default that makes sense but is not too crazy. 200 okay if it's deleted, or 204 no content. They're kind of interchangeable here. I see both. Neither one of them is really wrong. I tend to do 204 no content if it was deleted. There's nothing to return. The thing is gone. Your API client should know what to do with that. If you're working with like a CDN or some sort of cache or queuing jobs, 202 accepted, meaning like, yeah, this is a good request, this is okay, I'm going to deal with it later. That's a bit rare, but it's good to know that that is possible and that there is a way to handle things like that. I actually do have a small CDN set up and make use of that myself. And here's one you don't see a lot, and I'm trying to help people understand that this is a really cool feature. So there's an options header, and this is not for interacting with data. It's actually for telling clients things that are available to them. So you can return 200 or 204. There's not always content. If you're not going to do this, return 405 so that the client knows that, hey, this method isn't allowed. Like, you know, we don't do this. This is useful and should work on items but not collections within a resource. Same sort of deal. Don't delete a collection of users or messages. So this is basically just to show people what options are available to them. Let's dig into content types. If you can, return more than one. If you design your API right, you can even do cool things like accept JSON and return XML. That's actually kind of common these days. Same sort of deal with like YAML or whatever sort of thing you want to return. There are people who are submitting XML and then getting JavaScript back. I've seen that a few times. It works for them. Who am I to judge? So different clients have different needs. At my last job, we actually had a guy who was using an API via a Cisco router. And I guess the Cisco routers, they speak XML natively. They do not speak JSON natively. So we had to basically create kind of a middleware for him in order to translate the XML and the JSON, because our API, unfortunately, did not support XML, which is what he needed. So if you can get away with it, if you're designing this from the ground up, then try to implement that. And once you implement, you know, JSON and XML, then it's not a huge stretch to implement YAML or whatever, Markdown, see a whole bunch of things. You know, just adding additional content types is not that difficult once you plan for this. If you only allow one type, please inform your users that the others are not allowed. You can use the content type header to receive and parse this data, and the accept header to see what the client wants back. Like I said, you can accept XML and return JSON, things like that. The client can tell you that, and that's pretty cool. For simplicity, you can just send back what they send. I do that a lot. If you send me JSON, I'm just going to send you JSON back. So replies. Provide information on failures beyond the status codes. I mentioned there's a status code for a whole bunch of stuff. Don't just send them a status code. Sometimes that's okay. Sometimes that's not okay. You know, if there's an authorization error, or you know, this is you know, maybe your API key doesn't have permission to modify a resource. That's better than just getting 403, right? You know, then they can reach out to somebody and be like, hey, you know, my API key doesn't have permission to do this. Can I get permission to do that? And you know, they can kind of debug that a little bit easier. In general, there's a whole bunch of different series of codes. The 200s, the 300s, the 500 we screwed up. And the codes kind of let the client decide what they want to do next. So if everything's okay, they can proceed on to something else. If things are not okay, then maybe they can do something else with that information. There's no standard error message format, and we'll start to see here in a little bit that when it comes to REST APIs, it's still kind of the wild, wild west. People are really trying to get standardization across endpoints and error messages and things like that. We're not quite there. So you can kind of use your best judgment when it comes to stuff like this. Google is trying. They're trying really hard. HP also has an initiative. JSON API is also another initiative trying to get standard error messages, but that's not really a thing just yet. And the status codes are not Pokemon. You do not need to use every single one of them. In general, yes, you should try to use them to be as descriptive as possible, but don't feel like you need to use every single status code at some point in your API, because you really don't. So this could actually be its own talk. I'm going to gloss over this briefly, but this can get pretty crazy. So there's this concept of HADIAS, and it's hypermedia as the engine of application state. So you provide hypertext links to other resources. Think of it like links on a page. You know, if you are at a resource, you'll get a link to maybe you want to update it, or maybe you want to delete it, things like that. Hypermedia kind of drives that, and your client can kind of keep track of the state of things on its own. And it's giving a list of actions for your client to take. This is incredibly hard to do. It requires some forethought into, hey, I'm on this endpoint. What kind of actions would I expect to take if I were a user? And this is where getting that feedback is really important. You know, maybe a client of yours comes up with something that they need that you just didn't think of. So definitely get their feedback into this and kind of help them navigate through your API. You know, you might have great documentation. Hopefully you have great documentation. But sometimes, you know, people, for whatever reason, they just don't want to read that. They just want to go to an endpoint, start messing around, and kind of see what your API can do. Yep.
So by trying to maintain state, would you put like maybe some session code in like the Hypermedia link or something?
No, so REST is stateless. It's not keeping track of any sessions, so every request has to be authenticated. So if you're trying to keep track of the state of things, that happens on the client side. And the API will provide you some information to kind of let you know what's going on in order for your API client to track the state. So clients have to know how to handle this. People are inevitably going to hard code it anyway. That's not really your problem. I mean, they're just going to do it. There's not a whole lot you can do to really stop that. So could really get off in the weeds with this. It's actually pretty difficult. Hopefully this is a simplified explanation for you. Hypermedia specs. Going back to the Wild Wild West thing, there is no spec for this. Wishful thinking to get a spec for this. And in some ways, it would actually be pretty difficult to get a spec for this because every API is going to be different. But there are people who are trying to standardize what sort of scenarios you would expose certain things in the API in. JSON API, your own custom thing, HAL. They're good starting points if you're trying to get into the hypermedia side of things. They're gaining adoption. They're actually pretty popular. So if you're interested in kind of dealing with some of the hypermedia stuff, those are actually pretty good starting places for you. Versioning. I mentioned not wanting to maintain several versions of an API. And there's several reasons for that. So this is really not the time to kind of just... my last job we called it YOLO deploy because you pretty much just put it out there and pray that it works. Not a good time to be doing that. So ideally you want to design so that you never have to version. We don't live in a perfect world. I know that's not feasible, but if you go into it trying to design it as if you are not ever allowed to version ever, you will go a lot further. Your API will take you a lot further and you will not have to version as quickly. So why wouldn't you want to version? Well, migrations are really hard. Anybody ever tried to migrate people from one version of an API to another? Yeah. How long did that take? Didn't happen?
Yeah, never really happened.
Yeah, so if an API is working for people, unless you're offering them something that's just ultra amazing, they're not going to switch. And you end up in a scenario where you're maintaining however many versions of your API. And you really got to deprecate carefully because some people have crazy change control processes. I worked with a financial institution for a while. Their change control was 6 months. It took them 6 months to roll out changes to anything in their infrastructure. That is a long time. And, you know, I don't agree with that process, but, you know, I can't tell them that. They should maybe get with the times. I don't know, but they all have their reasons for their change control processes. Not everybody can update in a weekend, you know. One developer shop, maybe they can do it, but, you know, larger companies, there's no way they're going to do that in a weekend. They're probably not even going to do it in a month, probably not within the next 3 months, because it's probably not a priority for them if it's already working. So the higher that version number gets, the more versions you have to maintain. But also the flip side of that is the higher that number gets, the less faith developers kind of have in your API. You know, if you're using version 7 of an API, it's like, well, how frequently do they change this? You know, why am I going to use this if this is just going to be changing and then, you know, not backwards compatible? So you really got to be careful when you go to version an API here. So when is a good time to version? Whenever you make backwards incompatible changes, creating new data models, munging things, if you kind of change the structure of the data, that's a great time to version an API. And when it no longer meets your needs, you know, if you have a pretty basic API and you want to release version 2 that exposes a ton more things, changes your data models, that's great. You know, that's a perfect time to version an API. And did you have a question?
Yeah, I'll let you finish.
Okay. But not when you're adding new resources or data fields. You know, ideally the API client is coded in such a way that it doesn't care. You know, it definitely expose those new things to the API client so that it can kind of discover those new things as needed. The developer can kind of see, hey, you know, there's this new endpoint available to me. Maybe I could do something with that. But, you know, in general, adding a new resource endpoint should not break anybody's code. What was your question?
Yeah, it was about new resources and just adding. So how would you just like update your documentation, like, hey, we have a new resource that you can start using?
Yeah, so for things like trying to get people to adopt, I actually try to do like email campaigns, do some docs things, maybe drop it in a newsletter, be like, hey, this new thing is available, also expose it. If people make a request to like api.mything.com or whatever, include it there as a resource that people can take advantage of. Yep, in the back.
So would you kind of describe it as like a point release where you know, nothing breaks, you can still use existing code against the API, it's just there's new stuff, and the point release allows you to map that to some documentation about the new stuff?
Yeah, exactly. It's exactly that, just a point release, so you can keep iterating on this. In general, I tend to not expose the point release to people, so if you're using like a version in a URL or something, I do like V1 and V2, not V2.4 or whatever, just for simplicity. We'll get into how to differentiate between different versions in just a sec. So version in the URI, this one is one of the most common ones that I see, and like I said, I tend to do V1 in the API. Sometimes you see things that don't have a version. It's just assumed to be the latest version. The version is obvious to users, but means that your relative path can't always be Hypermedia driven. You might have to do some extra legwork in order to include that V1 into that Hypermedia URL. But this is great for people who are just getting started with APIs. It's super obvious to see, like, hey, I'm using version 1 of the API, and maybe you can expose something in the API that says, that tells the user you're using version 1.4. So that would get into the point release thing. Yep.
Do you do like drop the version number and just have the resources point to the latest version number, or what?
Yep. We're going to talk about that right now. So versioning in the content type. So this is actually a header that you can send. You can assume that it's the latest version. You can default to a version if none is specified, and that's exactly what you're describing. The devs need to know that they need to send this, so this is where documentation comes into play. You know, if they're not sending that header, that's fine. You give them the default version, but try to tell them, like, hey, you need to send this, especially if you're depending on a specific version. You know, we're not guaranteeing that the thing that you're using right now is always going to work. So just for a quick example, content type, application, JSON plus V1. So using version 1 of the API, you want JSON, you're sending JSON, receiving JSON. This is cleaner for a lot of people, but not as obvious. So you see a lot of this too. There's nothing inherently wrong with it. It's just you need some good documentation around this. Yep.
Would you default to the latest version or an older version so that it wouldn't be always changing?
That kind of depends on your needs. I default to the latest version. I'm like, if you are just getting started with the API, I want you to be on the latest and greatest thing. And then as you start working with it, figure out what version you need, what version is going to meet your needs. I've seen people, they will default to version 1 because that's the version that most of their users are on as they're trying to migrate over to V2 or things like that. So you're probably going to be a better judge of that, knowing your own infrastructure. But you can go either way on that. I just tend to default to latest and greatest. So versioning in a custom header, you don't see this as much because it's actually kind of confusing for people. People who aren't expecting this are going to be like, okay, I sent you my request and you're not doing anything with it. Why aren't you doing anything with it? And this is especially true if you're not sending good error codes or making use of HTTP status codes. I actually worked with an API that did just this. They required a custom header. Was not really in their documentation. Their example code did not include any of the headers that you needed to send. Documentation was absolutely terrible. Was sending requests and was getting 200 OK as a response for every single thing. And it's like, well, it's obviously not OK because I can't actually request the data that I just put in there. So something is up. Eventually, it took several hours of emailing back and forth with support to realize, like, oh, you're not sending a custom header. Well, it's like, please put that in your documentation and save me several hours of frustration. So there's no standard on this. People, at my last job, we had, I worked at PagerDuty before working at GitLab. We had a PagerDuty specific header that people could send for some APIs. Nothing really wrong with this. It's just more confusing, more overhead. There are a lot of headers that will get you where you need to be. So if you don't have to create a custom header, try to avoid staying away from a custom header. So let's talk about caching. Anybody have an API that makes use of caching? No? Okay. So caching on the client side, this will help you scale. Kind of prevents people from hammering your API if they know that they need to cache requests. Things that don't change. If you've got a database of, we'll call it items in a catalog, and your inventory doesn't change all that much, then that might be something that you want to cache. If an item description is not changing frequently, that's something that an API client can cache because it's probably not going to change between their requests. You can use a cache control header. There are a bunch of different types to let people know like when the cache should expire, what sort of options are available, the absolute maximum age of the cache, and absolutely important that this information ends up in the docs because if you're handing someone an SDK that caches things by default, caches specific things, and not telling people, then they're going to get the same information and be like, yo dude, your API is not working, it's not actually updating any of this information. So imperative that that ends up in your documentation. So authentication, and this is an area where a lot of people get tripped up. I advise people to kill basic auth. You want to keep your user and password safe. There's a whole bunch of different methods of doing basic authentication, but I've seen a lot more bad stuff happen with it than good stuff. It is easy for people to get started with because they can just put their username and password in the URL string and just go to town and kind of do whatever they need to do. Except that a lot of people will put this in, a shell, and then it gets saved to their bash history. They'll put it in their browser, and then it's down in their browser history. So you can actually get into a lot of trouble with basic authentication without even realizing it. That's the worst part. So I tell people, get rid of basic auth if you can. Even over SSL, just try to get rid of it. You can look at something like OAuth. OAuth doesn't always make sense for every use case, especially for CLI apps. Sometimes it's inconvenient for people to go from CLI to like a website that then does all the token exchanging and things like that. But it's a good starting place. Hopefully more secure for your users than just using something like basic authentication. Affords you cool things. You can restrict domains that are allowed to authenticate. You can restrict the authentication to HTTPS, which you should definitely be doing regardless. Please do not send credentials over HTTP. please use SSL. So you gotta be careful with storing the tokens. Man-in-the-middle attacks are pretty common. People try to steal your OAuth credentials and things like that. So just considerations for when you're implementing authentication. And there's several ways to do this. You can implement JWT or whatever. Just my advice here is just not to use basic auth. So what about security? I treat all users as hostile. Even though most people are there to just get their information and find somewhere to be, there's always going to be that one person that's like, I'm here to mess things up. I'm here to ruin your day. Don't rely on a single method of security, and that's generally good practice even outside of APIs. Like, don't rely on a single method of security here. So I tend to apply layers of security. I have permissions-based API keys, so not everybody can access every single thing. I do this per app, not per account. This can depend on your architecture sometimes. The per account makes sense. I also make use of a DNSBL, actually several of them. So, you know, known bad IPs, IPs that are known for spamming and trying to break into stuff, they get blocked. They don't even make it to the API. Got to be careful about content length and depth limits. So people can create recursive queries that just tie up resources and just keep going and going and going and going. So if you're dealing with depths and things that return other things, you know, try to prevent people from going too far with that and tying up your architecture. Talk to a lot of people who don't consider SQL injection when working with an API. It's like, oh, well, it's CLI. I don't need to worry about it. Well, yeah, you do. So do not forget about basic things like SQL injection. Just because you're not using, you know, forms and doing things with like a typical website doesn't mean that your data doesn't need to be sanitized. And look into rate limiting and throttling. If you let people, they will hammer your API endlessly. We actually got into a situation where, at my last job, where someone was able to send 10,000 requests. Well, they tried to send 10,000 requests in 1 second. And that didn't work out for them. Fortunately, we rate limited that and returned like, hey dude, you need to slow down. We're not doing anything with this request. But, you know, had we not had that, that would have knocked us out. That would have knocked us offline quite easily. So we were working on an API that was sort of monolithic. We were trying to make it better. We were working on version 2 at the time, and the requests that they were making were actually pretty heavy ones, so that would have completely knocked part of the monolithic part of the infrastructure over, and we would have been dead in the water. So what about prototyping? There's a whole bunch of stuff out there that will take you from 0 to API in about an hour worth of work. So depending on what language you're using, I mean, just about all the major ones, there's some sort of framework for that will get you there. So I'm partial to Laravel and Lumen, PHP frameworks, pretty easy to get started with, pretty good documentation. Flask, Rails, Modulicious, you know, pretty much anything you can think of. They all have RESTful HTTP routing, or have some method for you to get to RESTful routing and allow you to use GET and POST and PUT and all that fun stuff. And there's a bunch of specs. Going back to the spec tools, you can use some of these spec tools to create things that you can import into a framework, and your routing will just be taken care of for you right off the bat. And some of the tools can even auto-generate the SDKs for you. There's one called API-matic. You upload your spec, you get SDKs in several different languages. As you're prototyping, Chrome has a REST API client. Postman's pretty good. It's my go-to for analyzing some of these requests as I'm working in one of these frameworks. JS Fiddle's another good one. You can use JavaScript to make requests to your API and kind of see what's going on there. It's another one that I lean on pretty heavily. So as you're working through this API, sometimes it makes sense to just roll your own thing and completely do things from scratch. That's totally fine. If you're just trying to mess around and get started, using a framework is not a bad way to go. There will be some overhead. The requests will probably be a little bit heftier just because of all the things built into the framework. It's a great starting place, though. There are a lot of people who start out on like a Laravel or Rails app, and kind of as it grows, maybe they scale back on the framework specific side of things and start rolling their own things. But this is a great way to get started. So let's pretend you've just spec'd out and prototyped the greatest API in the world, and you're ready to ship that out to the masses. What's next? You can't just ship it and forget about it, right? Be prepared for maintenance. As you sit down to create this thing, a maintenance plan should be in place. There are people who they release an API and then do absolutely nothing to maintain it, nothing in the way of documentation or anything like that. That's a huge mistake, and that's inconvenient for the people who are trying to use your API, even yourself. If you were creating an internal API and not documenting it, that's going to bite you, even internally. People outside of the company not going to see that as much, but you're going to feel it internally, and it's going to be frustrating for anybody who has to go in there and use it. Please don't launch and leave. Definitely allocate maintenance resources and figure out whether you want support to be through the community, through a paid subscription plan. Your business model is going to dictate what that looks like. I'm a big fan of, yep.
Oh, I didn't mean to interrupt.
Oh, no, it's fine.
But do you maybe this is framework specific, but like JavaDoc or PHPDoc or RDoc, like one of these tools to like code comment and turn that into your API documentation?
You definitely can. You can definitely do that. If you're using something like API Blueprint or Swagger, that can even turn into documentation for you. So you don't even need to go into the code itself in order to do the documentation. If you were coding from the spec is basically prime to become your documentation. And there's a Swagger utility for that, Raml utility, API Blueprint can automatically generate docs for you if you're using something like Apiary. So, but yeah, there are people who are using JavaDoc and PHPDoc and all of that stuff to do this as well. And that's especially true if you're just kind of coding it from scratch. Even if you have a design blueprint, sometimes it makes sense to put those comments inside of your code. So yeah, you can go either way on that one. So going back to maintenance, I'm a big fan of community-provided support. If people are using your thing, it's nice to provide support for that for free, because they're probably giving you money or something. It's also just kind of a nice thing to do. It's also helpful for getting other people onto your API. So if your support is public, if it's community run, or if you have some sort of forum, then other people can kind of see how you handle support requests. And that's actually brought in some leads for several companies that I've worked at. It's just, oh, I saw so-and-so is replying to things on the forum or Stack Overflow or whatever. It's like, that's really cool. It's really cool that there are people who will sit down and go over this with you and provide this support without any additional charge. Also cool for people to see, if there's common pitfalls in your API. It's great for getting product feedback into your product. You can kind of see what your users are requesting the most and things like that. But so can everybody else. So it's kind of puts a little bit of pressure on you to actually fix some of these things. Let's talk about things bad people do. And there's several of them. There's a company in particular, AT&T, who makes you log in to view API documentation. You have to create an account, you have to talk to a sales rep, and only then will they give you access to API documentation. And that's just to see if their API will meet your needs. So that's kind of crappy. And since this is an open sourcey conference, it's kind of counter to open source mentality to use documentation as a lead generation tool and like get people into a funnel. Like, that's gross. I'm kind of like anti-funnel. Like, I know when it happens. I'm sure everyone in this room knows when someone is trying to sell them something, and like, people don't like that. So don't make people log in to view your API documentation. That actually really only hurts you. It makes people salty about the experience, but also, if people are just browsing for APIs that maybe do things that your company is doing, they can't see that. They can't see that your API is going to be the one that meets their needs. So that's bad for you. Using HTTP without the S. There's a lot of that out there still. It's getting better, thankfully. But if you're launching a new API, or if you have an existing API, please make sure that that's using SSL. Not providing documentation. Unfortunately, more common than you think. No documentation is pretty much as bad as not having an API. Actually, maybe even worse. Documentation helps you, and it helps your end users. So please provide documentation. Like I mentioned, there are a ton of utilities that will help you get that out the door pretty quickly with minimal extra work on your part. So there's really no excuse to not have documentation these days. Requiring the username and the password in the URL structure. There's one API that I worked with. You had to submit your username and password into the URL structure to retrieve your API key. And then use your API key for the rest of the request. If your username and password worked to retrieve your API key, you'd grab your API key and use that in all of your requests. And I don't know who made that design decision. It was not me, but it was pretty insecure. Yep.
We have an evil vendor who does that as well.
Yeah.
Where they want you to pass the name and URL in the query, in the URL itself. So, assuming we make our side of that relatively secure, like, is that information at risk in transit, or does it get protected through the HTTPS mechanism?
Should be protected. It kind of depends on how they're doing it. Should be protected in transit. Hopefully, it should be. I'll have to say it should be. There's not a whole lot you can do with that. If it's not your API, it's... I don't want to say it's not your problem, because it definitely is, but I mean, there's not a whole lot you can do. It's only as secure as they want to make it, really. And as secure as you want to retrieve it. So, yeah, like I said, some of this can be saved in the browser, in the CLI. There are people who do this and, accept requests over HTTP and HTTPS. So, I mean, you could even be sending all of their credentials, so their username and their password, and their API key over the internet in plain text. And that's just a really, really bad situation to be in. So try not to do that, please. Going back to SDKs, it's nice when these are provided to users. It's not always feasible, doesn't always make sense. If you're a smaller shop, maybe you just don't have the resources for this. Maybe you don't like some of the automatically generated SDKs, and that's fine. But it's nice to provide it to your users, even if it's just example code. Like, hey, here's how you'd get started with something like this. You should have a maintenance plan for these SDKs like you do with your API. I recommend that people who are experts in the language, whether that's PHP or Java or Ruby or whatever, look over these just to make sure that there's nothing that's really obviously wrong with something like this. The hardest part about all this is keeping the SDKs in sync with changes made to your API. If you're using a blueprint thing or a spec generator, that's a little bit easier to keep in sync. If you're not using one of those tools, it's a lot harder. So anytime you make a change in the API, you need to make sure you're updating that back into the SDK. It's super, super easy for all of that to get out of sync, especially if you have multiple people working on your API. Documentation. One of the most important things. If you have to choose between SDKs and documentation, choose documentation every time. Users should be immersed within minutes, not within hours. They should be able to come to a site and start using your API almost immediately. You know, there's no reason they should have to scroll through 7 hours of documentation just to figure out how to make a request. That's terrible and not all that useful to them. So, yeah, API is useless if no one really knows how to use it. It should absolutely be included in part of your design process. As you sit down to design this API, also be thinking about how you plan to document this API here. Try to make it all inclusive if you can. You know, include the errors and methods and parameters at a minimum. It should kind of work to be a reference and a tutorial. So I'm a big fan of people. So Twilio is actually a really good example. I love their documentation. Not only is it a reference, so if you kind of know what you're doing, you can just kind of go Google things and find the relevant Twilio documentation. They also have an entire, portion of their site dedicated to tutorials. Here's how you do a specific thing with their API. Here's how you, do this and this and this. They're actually really cool about making like these little dummy apps that do various things. So like send cat pictures to people. That's actually a tutorial. Like you can use Twilio to send cat pictures to people. Cat facts and all of that stuff. So that's really cool. Probably not feasible for a lot of people unless you're a larger shop. But still, if you can do stuff like that, it's really cool to see. Needs to be in sync with changes to your API. Pretty difficult unless you're using a tool. Include how to get help. And if you can open source this, try to do that. My last job, we open sourced our documentation and actually had people adding things. We had a place where people could add projects that they made built on top of the API and had people doing that all the time. But including how to get help, super important and often forgotten in documentation. It's like, documentation's great, but if this is not working for me, who do I contact? How do I get help with this? So I've said a lot of things, a lot of best practice things. The best API is usually the one that exists. So a common mistake for people is to force users to scrape HTML and things like that. That adds a lot of overhead to you. I worked with a client, and they were able to cut their AWS expenditure by $200,000 a year by creating an API. I kid you not, because people were scraping their website and getting data, and that was costing them so much in bandwidth fees that creating an API that was significantly lower bandwidth, not loading all the JavaScript and the images and all the assets and things like that, that saved them $200,000 a year. So that's a real thing. So yeah, try to design your API the best way that you can. But in general, if you find yourself in a situation where people are scraping your API, the best API is the one that exists. So I threw a lot of information at you today, and there are several places you can go to find out more if you'd like. There's a book by Phil Sturgeon called Build APIs You Won't Hate that will actually walk you through creating an API with using the Laravel framework. It's a PHP framework, but a lot of the information is PHP agnostic, so there are some implementation details that are related to PHP, but a lot of the information in there is good for whatever language you happen to be using. Undisturbed REST is more of a high-level, not as in-depth, zero to API kind of book by Mike Stowe. It's pretty good if you want to get more of an in-depth overview of the things that I discussed here today. Take a look at Apiary. Definitely take a look at Swagger 2. just to kind of get a feel for the landscape of these spec tools. There's a book called RESTful Web APIs that's put out by O'Reilly as well that goes very in-depth and actually talks about REST pretty deeply, and you actually build an API at the end of it. So that's all I have for you. Thank you so much.